Hello and welcome back to another LookdevX video. In the previous videos, I showed you how to create complex shading networks and showed you all the techniques that would allow you to create a very sophisticated shader. In this video, I want to show you exactly that. It will not be a step-by-step video, but I will show you the overall process that helped me to achieve this look here. Granted, I added a couple of lights to highlight some speculars and all of that. Right, so now let me minimize the render view, and you can already see that I also have enabled viewport shading. We get actually some nice bump on the viewport. We get specular roughness on the viewport. And if we want, we can enable the lights. They are a little bit overblown, so I don't think there's a good separation between the viewport and the render for exposure. In terms of if you crank them up, it just blows out. But never mind. That is not the part of this video. So as you can see in the LookdevX graph here, it's definitely way more complicated than the previous videos. And you can see I also exposed a couple of parameters on the material container. You can see we've got dirt level, wet look, body color, and this is something you would typically see in a production environment. Sometimes the dinosaur walks through, or it's raining, or I don't know, it's in a puddle of water. You have an option on a per shot basis to change the look. So you have now a wet slider essentially, or in USD land, you probably could load a variation, but imagine it would kind of fade in. So you have a way to animate this if you need to. And then we've got also dirt levels ranging, going up his leg or the dinosaur's leg until it's covered the full body. So let me preview this. So if I open up the Arnold render view, or we can also do it in the viewport. And now let's say we want to change the dirt level. So if I go maybe up to 50 here, you can now see that the full body is getting kind of dirtied up. And if we go a little bit less, you will see it starts kind of to ramp in and maybe go back down to 10. And you can see it's kind of creeping up the leg here. And this is done using a state vector. We will show that in detail a little bit later. And then we also have the wet look. So if I crank this up to 1, you can see that we're adjusting the overall look. It's using a code and a normal. So there's a complementary value driving the roughness and the bump maps. So maybe a wet look of 0.3 will blend in the code a little bit. And then you have a dinosaur looking like that. So on 0, it's off, and 1, it's fully on. And then I just created a simple mask within the shader. Probably want to get texture department to paint specific masks, but I could now, for instance, just change a certain value, and now we are changing the whole body color, keeping the lower jaw and the teeth, but then adjusting the top levels. And this could also be a case where you have different variations, or it's getting tan, or there's just something going on to change the color. So this value could quite easily be exposed to the artists working on the shots. All right, now let me first show you what I've done to get the viewport working as we have. And in one of the earlier videos, I showed you how to use Material X graphs, how to use the Material X library, and how to use the Arnold library. And the viewport is supported using the Material X libraries. And at the bottom here, I have a very simple version of my main shader. So the standard surface here is this ND, which means it's using the Material X library. And then I have a couple image readers. So this is just using the base color. This is my roughness, and this is my normal. And now I can quite easily, for instance, change the roughness values in the viewport. So that's quite nice to get a nice representation. I can change the scale of the bump maps. It's all happening live in the viewer. And then obviously I could color correct it if I need to. So I could create what's called LDK color correct, and then I could hook it up in here. This would be my input. Out goes to base color. And you can see already now, oh, why is it complaining? And the problem is, or the difference is, that this is getting the wrong type. And so this expects RGB, and this outputs RGBA. So instead of using this connection, you can try to just go one by one to directly connect them like that. And then we should not get any issues. There we go, no issues. And now, either way, we have full control about the hue shifting. So we could now, for instance, hook up our masking as well, change the saturation. This is all now in the viewport. So that's pretty nice. It's a good way to represent the stuff in, let's say, the lighting environment. And now let's actually dive into all of this. It seems probably like a lot, but if we go through it one by one, it will make sense quite quickly. Input, this is obviously what is coming in from our material container. We've got our exposed parameters, body color, wet look, and dirt level. And if I hop in here, the first thing you see is we've got the textures backdrop, and this is using the compounds we created in previous videos. If I dive in here, this is now the roughness compound loader. We've got a couple of values tweaked, base color, height. All of these are coming in nicely in this texture backdrop. And then the first thing is our main shader. We are not using the base color. We are just using subsurface scattering. I enabled random walk V2. Weight is on 1, and then radius is just a yellow. I don't know. I thought it's something like a lighter plastic when it's being emitted. And then the color is driven by our base color texture, which in turn is then going through this masking. So now let me preview that. And you can also see if you hover over these nodes, you get this S. So I can just click that to solo, and you can see what using the range, I just isolated the upper part, and the range is just clamping or like limiting the colors. And then the color correction just applies if I change the values now. The hue is obviously linked to the top level, but I could now, just for demo's sake, increase the gamma, and you can see only the top part changes. All right, that's that. And then we also have the roughness. So we're going first from our texture into our max. So the max is plussing essentially two values, or taking the bigger value from the texture or this range node. And the range node is just a noise which I created down below, this noise here. And then I'm just maxing that with my base texture, and you can see we've got the high frequency texture, and then the lower frequency, just a bigger breakup on top of that. And then a range to just limit the maximum roughness values, and the same applies to the top range, which goes to the code roughness. That's quite straightforward. And then at the bottom, I do have a couple of noise operations, and the daisy chain above, like this daisy chain here, is for the wet look, and the bottom one here first is loading in the normal. So I visualize that. This would be my normal, and then this goes into our normal map here, and this goes into the shaders normal. So that's nothing difficult or crazy. What is cool here, I'm using the same noise for the roughness, and I'm blending it using the bump 2D and the normal map. So the normal map has a normal input where you can pipe in a bump 2D node. So it's essentially a scalar to a vector. So quite handy. The top section here, let me explain what is going on here. First, we've got the wet look value. It goes from 0 to 1. And to drive the normal map for the wet look, you need to imagine if something is really wet, the water level rises in the crevices, which means the surface gets smoother and smoother. That's why you see, if you're on a street, for instance, you get really clear reflections because the water level has risen and there's essentially no bump of the tarmac. And that's kind of the philosophy here I'm going with. So I'm using the slider. It's right now on 0. I'm inverting this to 1, and then I'm clamping it like that. And currently the code is disabled, right? Because our wet look is on 0. So if I enable the wet look to 1, you can now see that everything adjusts. If the wet look is on 1, you can see that I'm driving the normal map. If the wet look is on 0, that means the code is off, which means the normal doesn't have any effect. And now if I visualize it, you can see that it gets very glossy, and that is because we are driving the bump map or the normal maps using that slider. So if I lower this, reducing the wet look, which means the surface gets more rough, we are increasing the bump. You can see now it gets very bumpy. And if it's 0 at some point, it just turns off, and then we have the regular default geometry bump. That's kind of how it works. And now let's have a look what else we're missing. If we go up a little, we can see that there's also a mix shader involved. If I visualize the shader, it's just a very basic base color texture from our original texture. And then this is just going through a color correction, which just, makes it yellow. Probably you would need to get a better texture from the texture department. But in this case, I just wanted to show what could be done. And now how did I drive the height going up the legs? In the moment here, I'm using the state vector set to position pass. If I visualize it, it's essentially a position pass from 0 to 1. Because it's in the origin, this works. You can also change the mode to object position. Then it's a little bit different because per object, it has its own coordinate system. In this case, I want to use position. That works well. And if you want to have it, if your character is moving, you would probably need to use a rest position or bake it so you can actually have it not sliding. In this case, it would slide. Either way, I look at the noise. It's essentially, it's probably will be, it's a little bit oversaturated now. I'm just using the green or one of the red channel here in the range, and the range is being driven by this noise. So the range is going from 0 to 1, and then I can offset that using the input max in the end. And the input max, if I visualize that, you can see it's kind of just on the legs here. And if I visualize my output, you can see now it's at the bottom. And if I increase now the dirt level, you can see that it's just moving everything up, and whatever is black will be my dirt shader. And then you can kind of dial it in. There's surely better ways to dial it in. Right now, it's just a noise. But again, it's just a showcase how you could set things up. Then you have it. So at dirt level of 25, you can see it's overall a little bit dusty. And then the legs, I'm changing the roughness values because the dirt shader itself is quite rough. If I visualize that, you can see how rough that is. And if we want it to be more, we can probably do even further dirtying up. We probably would need to increase the diffuse roughness. So it's just a different diffuse model. We could probably reduce the IOR slightly. And if I now hit Shift X to disable solo, and we should now have a more dry looking dirt levels. And you can see there's a nicer gradient. And if we increase it maybe to dirt level of 30 or 50, you can see now the whole dinosaur gets dirtied up. So it's a pretty cool way to easily control your shaders. And again, using the material container and compounds, you have a lot of flexibility to drive the look in a very granular fashion. For productions, you can really customize the way you want to work and expose certain parameters to your artists so they only work in a certain space and they don't have access to the whole network. And this ensures plausible physical correctness to your materials, and then just ensures the artists don't overcomplicate things. And again, we are using here the recommended workflow I showed in previous videos, where you have your modeling top section, and then you've got sublayers for the material and a binding sublayer for the assignments. Again, this is just a workflow that I used to like to work with. But yeah, there's definitely ways of improving what I showed, but I think this is an overall good indication of the complexity you can quite easily achieve using LookdevX and Maya.